function g of x is defined on the interval 0 to 8 with the values in the table below. So as you see, this goes up by 1 every time, and this seems to fluctuate just a teensy bit. Based on the table, on which intervals is g of x increasing? All right, well, let's find out what we're dealing with here. So we are looking for when g of x is increasing, and so that happens starting from 0 immediately. It goes from -4 to -3 to -2, and then all of a sudden drops down to -5. So let's just keep this guy going because why not? At -6, we go to -3, so all of a sudden we add again, we add 2 here, and then we drop down again, and then we drop down 1. So it looks like the adding part seems to happen between 0 and 2. Okay, so we'll include 2 there because, that's kind of included. Remember, keep in mind, these little parentheses mean that you don't necessarily include the number. You're just going up to that number. So from 0 to 1.99999 is basically us saying 0 to 2, but don't include 2. And also, where else do we get these pluses? We get these pluses from 4 all the way up to basically 6. So 0 to 2 is one option, and then we'll union it 4 to 6. So we'll go with C as our answer right there, baby. The table below shows the distance d of t in meters of an object over time t in seconds. So we have time t in seconds. We got 10, 13, 19. No pattern, no special order here except that it is in order. And these just go down in some particular non-order either. Doesn't matter. So what we're trying to find is the average rate of change. Now the general formula for average rate of change is f of b minus f of a over b minus a. Obviously in this case we don't have f's, we have d's. So this would be d of b minus d of a over b minus a. A and B are going to be these intervals. Your A, your B. So your A and your B. What would be f of b, or in our case d of b, and what would be f of a or d of a? Well, you would be d of a, and you would be d of b, because this is the result that we get for plugging in a and b respectively. So d of b is 30, minus d of a is 76, all over b, which is 25, minus a, which is 13. So what is that? -46 over 12, which simplifies out to they're both divisible by 2. So -23 over 6. And since this is a rate of change, it's going to be meters per second. So -23 over 6 meters per second, which seems to match up with B. Average rate of change with the table. Different from when you have a function or when you have a graph. It's a little bit friendlier in this case. Just label things, plug stuff in, do a little bit of math, you're set. Which of the following statements is false about the graph on the right? So we want the lie. The double would love that, that's for sure. The function is increasing on the interval -2 to regular 2. Well, increasing means it's just going up and to the right. Just because there's two different types of rates going on here, you have a slope of 1, you have a slope of 3, it looks like, doesn't mean that it's not increasing the whole way. It is increasing the whole way. So this guy is a true statement, which means you are not the option that we want. Let's take a look at B. The average rate of change on the interval 1, 5 is 0. Here's 1, so that lines up with 3. Here's 5, so that also lines up with 3. So average rate of change of 2 points is going to be the slope of those 2 points. Since that's a horizontal line, the slope is 0. You are indeed a true statement, which means I don't want you. Let's take a look at the next one. The rate of change on the interval 2, 6, so here's 2 right here, 2 to 6, is decreasing and constant. Well, let me tell you one thing, it's definitely not constant. The rate of change is not constant, so therefore this is false, this is the lie, so that's the guy that we want. Now the last one, let's just make sure. Instantaneous rate of change means the slope at that moment. We care about where x equals -1. X equals -1 is attached to this red line that has a slope of 1. So the instantaneous rate of change is the slope at that moment. The slope is 1. This is a true statement. So we were good by suggesting that C is our guy. And that's how you do that problem right there. Fun stuff. The table below shows values of a function y for different values of x. So x goes up by 1 every time, y is all over the place. Based on the data in the table, what type of function best describes the relationship between x and y? Well, what we have here in x is this goes up by the same number. So we're talking about equal length input values, right? So since you go up by 1, what I need to do is I need to test what these guys do, and I just simply say, all right, well, if it's linear, then these guys are going to go up by the same number every single time. So let's see if that's the case. Let's see if these guys go up by the same number every time. 2 to 0 is -2. 0 to 0 is 0, so it's definitely not linear. 0 to 2 is 2, 2 to 6 is 4, 6 to 12 is 6, 12 to 20 is 8. So this is not linear because the average rate of change is not constant. So we check to see if it's quadratic by doing the same thing, but with our linear values. To get from -2 to 0, you add 2. To get from 0 to 2, you add 2. 2 to 4, add 2. 4 to 6, add 2. 6 to 8, add 2. Since the average rate of change of the rate of change is a constant number, this is quadratic. So that's going to be our answer. No such thing as both. And neither would be if the quadratic gets you a different number. But since the quadratic gave you a constant 2 every single time, we can say it is quadratic. The table below gives values of the function g of x for selected values of x. So x, you have 0, 2, 4, so those go up by 2 every time, so equal length input value intervals. And g of x is, I don't know, it's a mess. But what we do know is it's quadratic. So what is the value of g of 8? Well, let's see what we can do here. If it's quadratic, okay, we should be able to find the rate of change of the rate of change. I put my arrow backwards. Let's try that again. So if it was linear, we would test this average rate of change by doing this guy right here. So to get from -5 to -1, you add 4. And to get from -1 to 0, you add 1. So which means the quadratic, the average rate of change, is going to change by subtracting 3 every time. Okay, so my job is to find out what happens at g of 8. So let's add 2 more spaces to this, 6 and 8. Okay, now what's happening again is I'm going to go backwards here. This guy is going to be -3. This guy is going to be -3. All right, so that would make you going from 1 minus 3 is going to be -2. And you, and that would be from 0 to 6. So let me change that, make it look a little bit better, -2. And in order to subtract 3 again, you would be a change of -5. So 0 minus 2 is going to be -2. I can handle that. And -2 minus 5 is -7. Therefore making our guy -7. Okay, so we kind of did backwardsy looking stuff. And that's how you do it. Fun stuff. Happy times. Name the 2 inflection points on the graph below. Well, an inflection point is where concavity is changed. So it could look like this, where it changes from concave down to concave up, or it could look like this, where it changes from concave up to concave down. Okay, so if I look at this without even looking at my options, we're concave up, and then all of a sudden at B, it switches to concave down. Now this is still concave down, and it might be tempting to say E is an inflection point, but at E, we still keep at concave down. So it's not like there's a change in concavity. There's just like, 2 concave downs next to each other. Change in concavity happens when we are from concave down, then all of a sudden G, we're at concave up again. So B and G are going to be my inflection points, and that's going to be that guy right there. What is the average rate of change of the function f of x equals 3x squared minus 1 on the interval -2, 6? The average rate of change is found by doing f of b minus f of a over b minus a. What's a and b? Well, that's going to be your interval. So I already have my a, I have my b. What I need to do is I need to use this formula to find f of a and f of b. So f of b is me finding f of 6. Okay? And f of 6 is me throwing in 6 into that guy and solving. 3 times 6 squared minus 1 is going to be 3 times 36 minus 1, which is going to be 108 minus 1, which is 107. Now I can find out f of a by doing the same thing but plugging in -2. So f of -2 is going to be 3 times that's a 4. I was working ahead in my brain. 3 times -2 squared minus 1, which is 3 times positive 4 minus 1, which is 12 minus 1, which is 11. So f of b was 107, minus f of a was 11. B was 6, minus a was -2. So that's going to get me 96 over 8, which I believe is 12. So C is going to be my answer for that one. Which statement about the function is false? Ooh, I want a false statement. All right, well, let's see what we got here. Y is a quadratic function. The x's go up by 1s every single time, so that's equal length input value intervals. All right, so I don't have to worry too much about that. I have to first find out if it's quadratic, see if it's linear. So in order to find out if it's linear, let's see if these go up or down by the same number every time. So to get from 6 to 0, you subtract 6, then subtract 4. So it's not linear because those numbers changed already. Minus 2, do nothing, add 2, add 4, and add 6. So it's definitely not linear. Now, it looks pretty quadratic to me because you go like this with the linear numbers to see if it's quadratic. You're finding the average rate of change of the rates of change. So you add 2, 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 you add 2. This is quadratic. This is a true statement, but I want the false one, so I don't want A. Okay? Bada bing. The average rate of change on the interval -2 to 2 is 1. So average rate of change formula is found by doing f of b minus f of a over b minus a. So a and b are going to be the intervals. So you would be my a and b. So if you're going to be my a and you're going to be my b, then you would basically be my f of a and you would basically be my f of b. So in this case, we've got f of b, which is -4, minus f of a, which is nerfing, over b, which is 2, minus -2, and -4 over regular 4 is -1. So we were supposed to get 1. We got -1. This is the lie. This is the lie. Now let's make sure that the other guys are good. Okay. In order to find if something is concave up, what you do is you find out where the rate of change, or if the rate of change is increasing. In other words, if I were to look at the rate of change, all right, I'm looking at my linear values, and my linear values are increasing. I'm going from -6 to -4 to -2 to 0 to 2 to 4 to 6. Those numbers are increasing. Okay, so this is concave up. This was a true statement, which means we didn't want U. And last but not least, let's make sure D is a true statement. The zeros are at -2 and 3, which means if I were to plug in -2, do I get 0? Yup. And if I were to plug in 3, do I get 0? Yup. So the zeros are at -2 and 3. U were true, which means I didn't want U, and B was definitely the guy that I needed. The polynomial function g is given by g of x equals x minus 2 times the quantity 4x minus 2 squared. Which of the following descriptions is true? So they're looking at polynomial degrees and leading coefficients. So this is a shortcut when you have something that's factored out and you're squaring one of those things. I have an x, so I'm going to, and if we're talking about the leading coefficient, we're just talking about the leading terms of each one. So I have an x times a 4x times a 4x. Why two of them? Because it's squared. So x times 4x times 4x really quick is going to be 4 times 4. X times x times x, 16x cubed. Now the rest of this is arbitrary because we only care about the leading term. So this is a polynomial with degree 3, so you are good and you are not. And the leading coefficient is 16, which means you are good. So D is going to be my answer for this one. For the polynomial function h, the rate of change of h is increasing for x is less than 3 and decreasing for x is greater than 3. So the rate of change is increasing, which implies concave up. And then once we hit 3, it changes from the rate of change decreasing, which implies concave down. Now, this happens at 3, so less than 3 is this information, greater than 3 is this information, which means at 3, that happens, we have what's called an inflection point. So we're probably going to be asked about that. The graph of h has a minimum at x equals 3? No. The graph of h has a maximum at x equals 3? No. The graph of h has a point of inflection at x equals 3. Is concave down for x is less than 3? No. And concave up for x is greater than 3? No. The graph of h has a point of inflection at x equals 3? Check. Concave up for x is less than 3? Check. And concave down for x is greater than 3? Check, check, check. Mate. That's how you do that guy right there. For the function p of x equals x minus 7 times the quantity x minus 1 squared, when is p of x less than or equal to 0? All right, well, in order to do this, we have to kind of look at three things. Thing number one, what are our zeros? Thing number two is multiplicity, right? And then thing number three is what does the graph look like by using the leading term? And by there, we can make ourselves a sign table. So my zeros are when these guys are equal to 0. So if I have x minus 7, I have a 0 at 7. And if I have x minus 1, I have a 0 at 1. Now what's important here, so I did that part. What's important here is I notice that my multiplicity for 1 is 2. Now what does that look like graphically? That means as this hits the x-axis, it'll bounce right off. Now what I also notice is my leading term is going to be x times x times x. Now why did I underline this twice? Well, because that parentheses is being squared. So I have an x times a parentheses times another parentheses, so x, x, and x are going to give me a leading term of positive x cubed, no coefficient, well, invisible 1 coefficient. So this is what this tells me. This is a cubic, or as I like to call it, a Drake cubic, because it starts from the bottom and now it's here. See what I did there? I made a song reference to Drake. I hear he's canceled though. So what I'm going to do is I'm going to make a sign table. I'm going to make a nice little number line right there. I'm going to label my zeros at 1 and 7. Okay, I know that I'm starting down here. So this is, I'm pretending that this is my x-axis. So I'm starting down here. What I also know is as I approach 1, the multiplicity is 2. So if I were to graph this on a regular coordinate plane, I'm going to hit 1 and ricochet right off. I'm going to come back down, and since the multiplicity of this guy is an odd number, I'm going to go through 7. Now my job is to find out where this is less than or equal to 0. In other words, where is this below or touching the line? I'm allowed to touch the line because it's allowed to be or equal to. So starting from the very beginning, starting at negative infinity, I'm already underneath the line. Okay, still underneath it, still underneath it, still underneath it, still underneath it. Right now I'm barely touching the line, but I'm allowed to touch the line. So I'm still underneath it, I'm still good, still underneath, still underneath, still underneath, still underneath. And it takes all the way up until 7 before I realize that I'm going to start being in positive land. Now I'm going to include 7 because at 7 we're at 0 and we're allowed to include 0. So everything else is going to be positive. Everything after 7 to positive infinity is going to be positive above the line, which means everything below the line exists from negative infinity to 7, which is going to be b. For the function p of x is equal to 3 minus 2x times the quantity x plus 2 squared times the quantity x minus 4, for which values of x is p of x less than 0. All right, so we have ourselves a gross-looking polynomial. Whenever you're asked to find out where it's above or below the x-axis, you're looking at 3 things first. Thing number 1 is you need the zeros. Okay? Once you find the zeros, you care about the multiplicity. And then once you figure out the multiplicity, you're going to find yourself your leading term so you know the behavior of the graph. So let's find our zeros first. Our zeros exist whenever each factor is equal to 0. Okay, so my 0 is going to be dependent for this first one on whether it's 3 minus 2x is equal to 0. So you might have to do a little bit of work, subtract 3 from both sides, divide by negative 2, divide by negative 2, and the 0 in this case is going to be positive 3 over 2. The other zeros are really nice. Okay, negative 2 is going to make that 0, positive 4 is going to make that 0. We found our zeros, Chekaruski. Now what we have to do is we have to find the multiplicity of each. The multiplicity of this guy is just 1, nothing fancy there. Okay, the multiplicity of the second one is 2. Now what does that mean graphically? We'll get there in a second. The multiplicity of the third guy is 1, easy peasy. Now the last thing I have to do is find out the leading term. You find out the leading term by taking the leading term of each parentheses and multiplying them to each other as many times as you're supposed to. Now in this case, I'm multiplying this second x twice. Why? Because the parentheses is squared. So my leading term is going to be found by multiplying negative 2x from u times positive x again times positive x a third time, which gives me negative 2x to the fourth. Now what that looks like graphically, and the reason why I do this, is I know this is going to look like an upside down m. Perfect? No. Accurate? Yes. Now what I do with all this information is I make myself a sign graph. I label my zeros, negative 2, 3 over 2, and 4. I'm starting at the bottom here, okay, and I'm going to make sure I notice that as I head towards negative 2, because I know it looks like this, but as I head towards negative 2, since the multiplicity of negative 2 is even, it's not going to go through negative 2. It's going to bounce off like that. Then it's going to come back up. It will go through 3 over 2 because the multiplicity is 1, come back down through 4 for the same exact reasons, and my end behavior goes down that way. So what I'm supposed to do with all this information is I'm supposed to find out when it's less than 0. Less than 0 means don't include 0. So right now, as I'm starting from left to right, I'm less than 0. I am below the x-axis. So everything up to this point right here is less than 0. And then all of a sudden I hit the x-axis. Now when I hit the x-axis, I am 0. I'm not allowed to include 0. So once I hit negative 2, I'm no longer negative. But the moment I keep going, I'm negative again. So I'm not including negative 2. So it sounds weird that I'm saying, let's go to negative 2 and then from negative 2, but that's how it is. So from negative 2 to positive 3 over 2, I'm negative again, right? And then the moment I hit 3 over 2, I'm no longer negative, I'm 0. Now I'm positive, now I'm positive, now I'm positive, but once I hit 4, I'm negative again. And it's going to stay that way forever. So from 4 on is going to be negative. So I go from negative infinity to negative 2, union, negative 2 to 3 over 2, union, 4 to infinity. A is going to be my guy. The function q of x is a polynomial of degree 3. If q of 3 is 0, that means if I plug in 3, which of the following must be true? Well, if I plug in 3, that means I have a factor of x minus 3 living in this polynomial. All right, I know that it's degree 3. it's cubic. So if I have a factor of x minus 3, that means this is going to be some type of quadratic going on in here. Okay, so which of these has to be true? If I plug in -3, I get 0? I don't know, so we can't say that. Q of x has 1 real 0 and 2 complex zeros? I don't know. I just know it's quadratic. That could be the case. If I use the quadratic formula on this guy, I could get negative square roots, but I don't know if that's going to happen or not. I can't prove anything, so B's not it. Q of x can be expressed as x minus 3 times p of x, where p of x is a polynomial of degree 2. So C seems to be good. But let's just make sure. Q of x can be expressed as p of x, where p of x is a polynomial of degree 5. I don't know where that came from. That's not even remotely true. I mean, that can't be true. These guys are possibilities, but this guy is definitely not. So C has got to be the only one that will make sense here. So C is going to be my answer. The following polynomial function f is given by f of x equals -7x to the 6th plus 2x squared plus 4. Which of the following statements about the end behavior is true? So in order to figure out the end behavior, we're looking at the leading term. This leading term is not only negative, but it also has a degree of 6, or an even degree. Something that is negative and has a degree of 6 starts from the bottom, does a couple little bumps, and ends at the bottom. Okay, so in this case, the limit as x approaches -infinity, as we're moving to the left without bound, of f of x is going downward, which is -infinity. As I move to the left, I go down, so the limit as x approaches -infinity is -infinity. Similarly, as I move to the right, the limit as x approaches +infinity of f of x, I'm going down again, which means that 2 is -infinity. So the limit as x approaches -infinity is -infinity, check, no, and the limit as x approaches +infinity is -infinity, check, no, no. Wait, hold on. Let's try that again. I tried to be cute here. I don't want to be cute. Check, no, yes, no, yes. Well, I hope that helped. Thanks for watching. Given the end behavior of the polynomial p of x in limit notation, I know that p of x is +infinity as the limit approaches +infinity. So the end is going to look like that. N, as the limit approaches -infinity, p of x's end behavior is also -infinity. So I start from the bottom, I end up at top, so kind of like Drake did. And this is only going to happen if first you have an odd degree, and if your leading term is positive. So I need a leading coefficient that's positive, check, and the degree is odd, check. We're at our answer already. Let's just double check. The leading coefficient's negative, nope. It is odd, but still not good enough. The leading coefficient is positive, yup. Even, nope. The leading coefficient is negative, nope. And it's even, nope. So, of course, A right off the bat works, and that's the one that we want. A linear function p is used to model the price in dollars of used trucks as a function of their age t in years. It is known that p of 3 equals $10,200, p of 6 is $6,600. So what this is saying is year 3, truck is worth that much, year 6, truck is worth that much. Based on this model, which of the following is true? Well, it tells me it's linear. So any of this percentage stuff isn't going to be linear, because what you're doing is every year you're taking a percent of the current cost and decreasing it by that much, which means it changes over time. So if you started out at, let's say, $20,000 and you took 25% of that, the car is now valued at $15,000, and 25% of that is different. So it's not going to be any of these percentage ones if it's supposed to be linear. So we need to figure out if this goes down by 1,800 or 1,200. Well, let's do this. If it starts at year 3, if it starts at 10,200, and now it's 6,600, right? And that was from year 3 to year 6, so we'll do 6 minus 3. We could kind of use the average rate of change to see what guide this is going to be. So 10,200 minus 6,600 is going to be 3,600. All that divided by 3 is going to be $1,200. So what you're seeing is this guy goes down by $1,200 every year from year 3 to year 6. Hope this helps. The function f is given by f of x equals 4x squared plus 1. Which of the following statements is true and supports the claim that f is an even function and not an odd function? Well, if something is an even function, what you're supposed to do is plug in negative x to every regular x. And when you do that, you get the original function spat back at you. Okay, so this is the rule for an even function. Now, if you were given an odd function, it would look like this. And I'm going to erase it in a second, but if you were given an odd function, what this means is if you plug in negative x, you get literally the entire opposite thing. That's if it's odd, but that's not what we're doing here. So let me erase that and pretend that that never happened. So what we have to do is we have to take every x value in f of x, plug in negative x, and see if we get the original function. So that's going to be 4 times negative x squared plus 1. 4 times negative x squared is just regular x squared plus 1. And so what we get here is we get the original function that we started out with. So in the same vein, if I were to plug in negative 2, I should get regular 2 if I were to get the original function back. So it's going to be C. So I don't know why I did all this stuff when I could have just looked at what I wrote here in red and got that. But that's all right. I did a little extra, and hopefully it helped a little bit more. Determine which statement describes the following notation. The limit as x approaches infinity of p of x is negative infinity. So we've got some wording here. Increases without bound, decreases. So let's look at this first and then figure out what we have going on. As x approaches infinity means going that way. The p of x approaching infinity means going that way. So the way we would word this, as x increases, okay, as x increases, p of x decreases. So when you see also other words like without bound, that means just forever. So we would word this as x increases, p of x is decreasing without bound. So we need the one that says the graph of the function p decreases. So you're solid so far. You're not, you're good. As x increases is the one that we want. So yeah, this is just a wording problem. This is just vocabulary and stuff like that. But again, this is saying that your graph is going down as x is moving along to the right. So the answer is A. The function f of x equals x minus 2 times x plus 5 times x minus 7 is a cubic polynomial. I see that. How many zeros and local extrema does the function have? Well, this is a regular cubic, and I know it's a regular cubic because it's an x times an x times an x, giving you a leading term of x cubed, no leading coefficient except for the fact that it's positive, which means you are going to look like that. Okay, now these go through 3 separate zeros, no multiplicity. So you go through 2, you go through negative 5, you go through 7. So it has 3 zeros. And if it's a regular old cubic with no weird multiplicity, nothing crazy like that, we're going to have 2 local extrema, a local maximum and a local minimum. Okay, so this has 3 zeros, 2 local extrema. The answer is going to be A. All right, so we didn't have to find out what they were. We didn't have to solve for anything. This is just one of those problems where we have to recognize what's going on and answer the question being given to us. All right, on to rationals. The function f of x equals x minus 8 times the quantity x plus 3 all over x squared plus 5x minus 24 is given. Which of the following describes the function f of x? So we need to find the domain and we need to find a horizontal asymptote. So we're hitting 2 things here. So this is what I have to do. I'm going to change this problem in 2 ways first. The first way that I'm going to change it is going to help me find the domain. So I'm not going to change the top. I'm going to leave the top factored out like so. What is that, a 3? I almost made it an 8. Whew. I'm going to leave the top factored out like that. I'm going to factor out the bottom, and two numbers that add up to 5 and multiply out to negative 24 are going to be x minus 8, x plus 3. Nope, x plus 8, x minus 3. That was a close one. So if I'm only focusing on the domain, I don't care about the top. Who cares? I'm only focusing on the numbers that I'm not allowed to plug in. And I'm not allowed to plug in negative 8 because that would make this guy 0, which would make the entire denominator 0, which makes the whole thing undefined. And I'm not allowed to plug in 3 because that would make that factor 0, which makes the whole bottom 0, which makes the whole thing undefined. So I am not allowed to plug in negative 8 and 3, which means I am allowed to plug in everything from negative infinity all the way up to negative 8, not including negative 8, so from negative 8 parentheses to negative 8 parentheses, all the way up to 3, right? And then union again, let me get rid of that comma, union again from 3 to infinity. So that is the domain that I'm allowed to use. This is me saying I'm allowed to plug in whatever I want, except not including negative 8 and not including 3. So that's going to take me not to here and not to here, but these guys are promising. Okay, now I have to find the horizontal asymptote. Now the horizontal asymptote is found by taking the leading coefficient divided by the leading coefficient. All right, so I'm going to do that by rewriting this guy and foiling out the top. So if I FOIL out the top, I get x squared plus 3x minus 8x is minus 5x minus 24. And that's all over x squared plus 5x minus 24. So we take the leading coefficient divided by the leading coefficient. Since the degrees are the same, it's literally just the leading coefficient, which is invisible 1, divided by the leading coefficient, which is invisible 1. And 1 divided by 1 is 1. And since this is a horizontal asymptote, it's going to be a horizontal line, which is y equals 1. So y equals 1 is going to be my leading coefficient, so not u and not u, which eliminates u. And it does have a horizontal asymptote. Now, if you're like, whoa, whoa, whoa. When won't it have a horizontal asymptote? If the degree in the numerator is higher than the degree in the denominator, then it won't. But since they're the same, everything simplifies out nicely to just a regular 1, which means my domain is u, and my horizontal asymptote is u, and my answer is u. Or as Soldier Boy would say, u! Oh, thanks for watching. The function f of x equals negative x cubed plus 3x squared plus x minus 5 all over 5x squared plus 7x minus 4 is given. Which of the following describes the end behavior of f? All right, so whenever you're trying to find the end behavior of a rational function, you take the leading term in the numerator and the leading term in the denominator and analyze that. Nothing else matters. So I have f of x equals negative x cubed divided by 5x squared. What you do to find the end behavior is, first off, we notice that the numerator's degree is higher than the denominator's degree, which means this is going to have end behavior at the infinities. We need to figure out which infinity it is. So why don't we simplify what we have? Negative x cubed over 5x squared is going to have me canceling out 2 x's in the numerator and the denominator, leaving me with a negative x on top and a 5 on the bottom. So the way you figure out end behavior when you have a larger degree in the numerator is you take turns plugging in your infinities and negative infinities. So they want me to do infinity first. So if I were to plug in positive infinity, which I know doesn't sound right, but that's what you do negative positive infinity over 5. Negative infinity divided by 5 is still negative infinity. So the limit as x approaches positive infinity, of f of x is going to be negative infinity. So positive infinity goes to negative infinity, check, nope, check, nope, nope. Now let's do it again with a negative infinity. If I were to take what I have up here in red and plug in negative infinity, it would look like negative infinity over 5. Negative is positive, so positive infinity divided by 5 is still positive infinity. So we can say that as x approaches negative infinity of f of x, we go towards positive infinity. So nope, yep, yep, nope, nope. Leaving us with C as our possible and only option that will work. The function f of x equals x squared plus 2x minus 24 over x minus 4 is given. Which of the following describes the function of x? So we're talking about x-intercepts here. We're talking about vertical asymptotes or holes here. So what we need to do is take this guy, factor out the numerator, and see what we get. So if I rewrite out f of x, and think of two numbers that add up to 2 and multiply out to negative 24. Those two numbers would be x plus 6, x minus 4. And that's going to be all over x minus 4. Now, whenever you have a rational function like this, you're looking for those three things. You're looking for first a 0, which by the way, x-intercept and 0 are the same exact thing. A 0 exists when you have just a factor upstairs and nothing like it downstairs, and that happens here. My magic numbers are going to be negative 6 because that makes this factor 0, positive 4 because that makes this factor 0, and positive 4. So since this factor up here is all alone by itself, you are a 0. Now, if you are looking for a hole exists where you have a factor upstairs that's the same exact thing as a factor downstairs, which means a hole is going to exist at 4. Now, what we don't have is a vertical asymptote. Those exist when you have a factor on the bottom that's nothing like a factor on the top. That doesn't exist here. The only thing we have is a 0, or they want us to word it as an x-intercept, same exact thing, at x equals negative 6, and we have a hole at x equals regular 4. And that's going to be B. So there you go, easy problem. Let f of x equals x times the quantity 4x minus 4 times the quantity x squared minus x minus 6 all over x plus 9. Which of the following x values would result in f of x is less than 0? This problem is terrible. So this is what I want to do. I want to get a nice visual of what this picture is going to look like so I can figure out what this guy is going to look like. Let's keep you the way you are, and then also factor you out off to the side here. So what I could do is leave x like x. Let's whip a 4 out and put it in front of that x, leaving us with x minus 1. Let's factor u out to x minus 3, x plus 2, and you can't do much with the bottom. Okay, you can't do much with the bottom, x plus 9. Now I have 4 factors living up here. Yes, you are a factor, so invisible parentheses right there. The magic numbers are going to be the numbers that make each factor equal to 0. So your magic number is 0 because plugging in 0 would make u 0 and make the whole thing 0. Same thing with 1, make u 0, the whole thing 0. Same thing with 3, same thing with negative 2. Okay, the magic number down here is negative 9. None of these numbers repeat, which means you are all zeros and you are a vertical asymptote. Okay, so if I were to graph this information so far, and again, by graphing, I mean we're going to sketch just a regular old graph, nothing fancy, right? We have negative 9 way over here, you're a vertical asymptote. Okay, we have negative 2 over here, we have 0 over here, we have 1 right here, and we have 3 right here. Okay, that's the information that we have so far. That's the information that we have so far. I can get more information, though, as to what this graph is going to look like. So information number 1 that I can get is I notice that, all right, well, I can find out what my y-intercept is by taking all the constants up here. So my constants would be, let me see, well, hold on. There is no constant up here. This is going to go through 0. How do I know that this is going to go through 0, 0? Because if I were to multiply everything out, I wouldn't have a plus 0 at the end. See, the way you find out what the y-intercept is you take whatever constant number that's upstairs and divide it by whatever constant number that's downstairs. Well, up here, my constant number would be a plus 0 because if I were to factor 4 throughout everything, I'm not going to have some number lingering around. So my y-intercept is going to be 0. So this is going to go through the origin. So that's going to count for something. That's going to count for something. Another thing that I can notice is I notice that, all right, well, I want to find out what the end behavior is so I can kind of draw a rough sketch of what this is going to be. The end behavior is found by taking x times 4x times x squared, which is 4x to the fourth, and dividing it by x. When you are positive and you are positive, A, and when B, your degree is higher than U, this goes to positive infinity as x moves along to the right and negative infinity as x moves along to the left. So that's going to be my end behavior. So I have enough information to draw myself a decent looking picture. So what this picture is going to look like is you're going to start down here. Okay, now as this is moving up, it's not going to hit a 0 at any point before my vertical asymptote. So this is going to come back down and never cross the x-axis and explode down there. Now since there's no multiplicity, it's going to reappear up here. Okay, it's going to come down, go through -2, and then come back up and go through 0. Okay. It's going to, now no asymptotes again, so it's going to come back down through the 1 and then back up through the regular 3 and go that way. Now, is this going to be the exact picture? No, absolutely not. But this is what this is going to give us. Now I have areas where I can tell where these numbers live. So for example, my job is to find out where stuff is negative. If x is -1, that means x is going to live somewhere in between here. That is negative, so you are a true statement so far. If x is 2, that means you're going to live between 1 and 3. That's negative as well. So you are also a true statement, so A is my answer right away. Now, if I were to look at an option that doesn't work, like B, if I were to plug in 0, I get 0, which is not less than 0. If I were to plug in 3, that is 0, which is not less than 0. If I were to plug in 5, that's going to live above the x-axis. So none of these would work. It's not like some of them would work. None of them would work. If I would plug in -8, that's over here. That's above the x-axis, so you don't work. If I were to plug in -4, same thing. That's above the x-axis. You wouldn't work. If I plugged in 6, that's way over here. That's above the x-axis. You wouldn't work. If I were to plug in 1, that's on the x-axis. You don't count. So A is the only option that works because of this picture that we were able to poorly, but accurately, somewhat accurately draw out. Very challenging problem, but we did it. In the xy plane, the graph of a rational function g of x has a vertical asymptote at x equals 2. Which of the following expressions could define g of x? So this is what we're looking at. Vertical asymptotes means you have a factor downstairs with, if it's x equals 2, is going to be x minus 2 because the 2 would make the bottom equal to 0. Now what I also see here is you have the potential of multiplicity. So either you have one of two options. You're going to have x minus 2 alone on the bottom, so that's option number 1. Or another option that you can have is if there has to be a repeat, if there has to be an x minus 2 over x minus 2, right now as this is written out, this is a whole. However, if I have more x minus 2's in the denominator, right, that's going to be a vertical asymptote. Now here's possible option number 3. Okay, and I'm not sure if that's going to show up here, but I'm noticing that there's some backwardsy things like U happening here. I just need a 2 to be the case. So if any of these x minus 2's actually look like 2 minus x's, that would still follow the rules because a 2 would make the bottom explode. Okay, so that's what we're looking at. So either an x minus 2 alone on the bottom, or an x minus 2 with more on the bottom, or a 2 minus x following the same exact rules. You have an x minus 2 upstairs and an x minus 2 downstairs. That's a whole because they're the same exact thing. A is not going to be an option. Okay, now you have this guy is basically, so x minus 2 is the same as that, it's just written backwards, but there's 2 of you up here and 2 of you down here. That is also a whole because it's the same exact amount, so you're not going to work. Okay, your 2 minus x on the bottom. Now before you freak out and say, that's 2 plus x, which means negative 2 is my magic number here, not regular 2. So since I have 2 on the bottom, which is more than I have up top, C is going to be my answer. Now to close this out, if you're wondering, well, why is D not going to work? Because the magic number down here is going to be negative 2, not positive 2. So I don't even have the option of a vertical asymptote at positive 2 for D. So D is not a possibility. So C is weird because, you're looking at things written kind of in reverse order. But C does work in this case because it makes the 2 my magic number. And if there's 2 of them, great. Let a of x over b of x be f of x, where a is a linear function that passes through the x-axis at 5, and b is a quadratic function that passes through the x-axis at -1 and 5. All right, so this is what this is saying. A of x has a 0 at 5, which means a of x is x minus 5. B of x is going to have zeros cross the x-axis at -1, which means a factor of +1, and +5, which means a factor of x minus 5. Since f of x is given to us as a of x over b of x, we can write this whole guy out as x minus 5 over x plus 1, x minus 5. They want the vertical asymptotes. So the magic numbers for these guys are the numbers that make every factor, and yes, that is a factor, 0. So 5 would make the top 0, -1 would make the bottom 0, and 5 would make the bottom 0. When we have the same amount of numbers on the top and the bottom, that is a whole. Okay, that is not what we want here, but bonus. What we want here is the fact that -1 is my magic number on the bottom. So I have a vertical asymptote living at x equals -1. And so therefore my answer is A, baby. Given the graph of f, which of the following describes the function of f? So we're looking at these options and they want left-handed and right-handed limits at 4. Now when you see something like this, the limit as x approaches 4 with a little negative, that means from the left. You are approaching 4, which is right here. And by the way, 4 appears to be a vertical asymptote. You are approaching 4 from the left. So this guy, which I'll demonstrate in blue, has me coming from the left. Oh no, an explosion. Oh, but we're not at 4 yet. Oh, we care about what's going on right here at this very moment. So the limit as x approaches 4 from the left is going to be going downward, which is -infinity. So similarly, the limit as x approaches 4 with a little plus sign means from the right. So as I go to 4 from the right, here I am, I'm going to 4, it didn't take long, we're going up, which means you're approaching +infinity. So the limit as x approaches 4 from the left is -infinity. So as x approaches 4 from the left is -infinity, check. Backwards, 4 from the left, -infinity, check. -infinity, check. +infinity, no, no. Okay. Also, as it approaches it from the right, we are going to +infinity. So from the right is -infinity, no. +infinity, check. +infinity, check. No. So did I make a problem where I literally have the same exact answer twice? Yes, I did. Stupid me. So thank you, ChatGPT, for failing me. Both of these guys will actually work. So I'm not sure why that happened when I made my problem, but it's basically literally the same exact answer, just flip-flopped. So in this one rare case, let's just pretend that this is select all that apply, and the answers are B and C. See, no problem, no harm, no foul. So the answer is B and C. Before Christ. The function g of x is given by g of x equals x minus 50 times the quantity x squared plus 90x plus 100 all over x squared minus 250. Which statement is false about g of x? So you want the lie. So let's see what we can do. Let's factor all this out. You can't do much with x minus 50. It's already x minus 50. This is going to be fun. Think of two numbers that add up to 90 and multiply out 100. Go ahead, think of it. You can't. They don't exist. You can't factor this out. At least not without our good friend, the quadratic formula, which I don't know if I need to whip out, but we'll see. Now on the bottom, this does factor out. This is difference of squares to x minus 50, x plus 50. So what's important to know about this guy right here, right, is let me just write out one more set of factoring things, okay? This is going to be x minus 50, nothing changes there. This does factor out, but both of these numbers are going to be ugly, terrible numbers because you would only be able to do this using the quadratic formula. So whatever numbers they are, they're not going to be pretty. It's not like they're going to factor out and you're going to get like x equals 1 and x equals, no, they're going to be bad. Down here, you get x minus 50 and x plus 50. So the magic numbers here are going to be 50, some negative ugly number, another negative ugly number, 50, and negative 50. So at the very least, this is what I definitely know, okay? What I definitely know. U and U are the same, which means 50 is a whole. Negative 50. And by the way, same thing with regular 50, since the only way that you're going to get answers for this, they're going to be ugly numbers, there's no way that any of them are going to be 50. So none of these are going to match up, none of them. So negative 50 is a vertical asymptote no matter what. And whatever these guys are, who cares, they're going to be zeros. Okay, so a whole exists at 50. Is that a true statement? Yes. I want the false statement, so A is not going to work for me. A vertical asymptote exists at negative 50. Is that a true statement? Yes, so you're not the one I want. This graph will appear linear. Now, a graph will appear linear if something like this happens. Now, this is what's going to happen. What the graph will look like is it will look like me crossing this out. So this graph is going to look like me getting rid of the x minus 50s and me being left with some ugly x, no comment, and another ugly x, no comment on my dating history, all over x plus 50. Now that's going to look like x squared blah 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 over x blah blah blah. That is not linear. That's not going to look linear. And before you get excited and say, but x squared over x, I know that, but nothing here is going to cross out. So this is going to maintain rational behavior. It's going to look like this, it's going to look like that, no matter what you do. Okay, so this will not appear linear, which means this is going to be my false statement. This is the one that I want. Okay, now if you're wondering g of 0 equals 2, what does that mean? Well, that means if I were to plug in 0, would I get 2? Well, let's find out if I were to plug in 0 by doing very quick math. If I plug in 0, you would go away, you would go away, you would go away, you would go away. So I would be left with negative 50 times 100, which is negative 5,000, over negative 2,500. Negative divided by a negative is a positive. 5,000 over 2,500 is 2. So you are a true statement. So C, this graph will appear linear, is the only one that won't work. It's the false one, which means it's the one that we want. We want the lie, and the devil is a liar. But in this case, we're going with it. So like and subscribe, please. Given a rational function with zeros at x equals 8 and x equals negative 5, a vertical asymptote at x equals negative 8, and a whole at 2, which of the following could represent the factored form of this function? All right, so let's build ourselves what we have. If it has a 0 at 8 and negative 5, that means you're going to have parentheses living in the numerator only. And the factors that you're going to build are going to be factors whose 8 and negative 5 make this whole thing equal to 0. So the only way that would work is if you have 8 you're going to make a factor of x minus 8, the opposite. If you have negative 5, you're going to have a factor of x plus 5, the opposite. Because plugging in 8 would make you 0, plugging in negative 5 would make you 0. That's the zeros part. If it has a vertical asymptote, that means there's going to be a factor living in the denominator all alone by itself. If negative 8 would make the factor equal to 0, then positive 8 is going to have to be my factor. If it has a hole at 2, that means you're going to have upstairs and downstairs being represented. Now, if it's at 2, a number that would make a factor turn into 0 would be its opposite, negative 2 and negative 2. So this is a possible factored form of the function. So x minus 8, x plus 5, x plus 2, nope. X minus 8, x plus 5, x minus 2, check. X plus 8, x minus 2, check. B is going to be my guy. Now let's just double check the others. X minus 8, nope. X minus 5, nope. And then x minus 8, x plus 5, good, but we're missing the x minus 2 up here. So you're a nope, you're a nope, and you're a nope, and you're the yes. So B is going to be my answer. Given the function f of x equals x squared minus x minus 6, which of the following describes the values of x for which f of x is greater than 0? Ugh. So this is what we have to do here. We have a lot going on. We have to find zeros, we have to find holes, and we have to find vertical asymptotes. Not only should we do that, we need to find the end behavior of what's going on here, and we really should find out what the y-intercept is. So let's leave that looking like that because I'm going to come back and reference this in a minute. Okay. What I also want to do is I want to factor out the numerator and the denominator because that would give me holes, vertical asymptotes, and zeros. So f of x is going to be factored out x minus 3, x plus 2. On the bottom in the denominator, we have x minus 3, x plus 3 because it's difference of squares. Now let's find the magic numbers, the numbers that would make each factor equal to 0. Your magic number is 3, your magic number is negative 2, your magic number is 3, your magic number is negative 3. So that would give you a, let me see, 3 and 3 repeat, so we would have a hole at x equals 3 because we have repetition there, top and bottom. Negative 2 is a magic number living alone in the numerator, so that is a 0 at x equals negative 2. And negative 3 is a magic number living alone in the denominator, so I'm going to have a vertical asymptote at negative 3. So if I were to draw some important information on a coordinate plane, if I were to sketch this, what I have so far is I have a hole happening at 3, I have a 0 happening at negative 2, and I have a vertical asymptote happening at negative 3. So this happens so far. What I also need to find out is a y-intercept and a horizontal asymptote. Let's do the horizontal asymptote first. Now the horizontal asymptote is going to live whenever you have either the degrees are the same in the numerator and the denominator, or the degree in the denominator is higher. You're going to have a horizontal asymptote. These are the same. So my horizontal asymptote is going to be at x squared over x squared. You're looking for the leading coefficient divided by the leading coefficient. Each leading coefficient is 1 and 1. So I'm going to have a horizontal asymptote at y equals 1. So if I were to call u1, this happens, horizontal asymptote at x equals 1, y equals 1, sorry. Now the other thing that I didn't find out is where this is going to be my y-intercept. My y-intercept happens when you have the constant number in the numerator divided by the constant number in the denominator. That is going to be my y-intercept, and that's going to happen at negative 6 over negative 9, which is going to be 2/3. So this is going to happen. Okay? So let's, again, evaluate what we have. We have a hole at 3. Okay? This is going to go through negative 2. Okay? Now, it levels out at 1. So since starting from the left, I have a picture that levels out at 1 right, but doesn't go through any zeros at all, and then all of a sudden explodes here at -3. What this is going to look like is it's going to level out at -1 or +1 and then go like this. That's what I have so far. Then, since there's no multiplicity ruining things, at -3, I'm going to reappear down there. And I'm going to come up and go through -2, through -2, because it's a 0, through that y-intercept of 2/3, and level out here while hitting a 0 or a hole at 3 right there. So that's going to be what my picture looks like. Now what I'm supposed to do is I'm supposed to find out where this is greater than 0. Okay, so this is going to be greater than 0 here. All right, it's going to be greater than 0 all the way up till -3. It's going to be positive. So all the way up until -3, it's going to be positive. Then from -3 to -2, we're negative. Okay, but then from here on out, from -2 all the way until positive infinity, we're living in positive land again. So it's going to be positive from -infinity to -3. Okay, it's going to be negative from -3 to -2, and then from -2 all the way on to positive infinity, we're above the x-axis again. Okay, so that is going to be A. And that's how you do it. Simplify the expression x minus 2 to the fifth, which of the following is the correct expanded form. Oh yes, Pascal's triangle and the binomial theorem. So what we need to do is we need to build 5 degrees of Pascal's triangle, which means 6 levels of Pascal's triangle. So degree 0 is 1, degree 1 is 1 and 1, degree 2 is 1, 2, 1, degree 3 is going to be 1, 3, 3, 1. And by the way that I'm doing this is add u up to get 3, add u up to get 3. So the next one is going to always be 1 on the outside. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then 1. This is 1, 2, 3, 4, 5. So the next one is the last one that we have to do. So degree 0, degree 1, degree 2, degree 3, degree 4, and degree 5 is going to be 1, 5, 10, 10, 5, 1. So building our binomial theorem has me start out with writing these numbers. So 1, 5, 10, 10, 5, 1. Then what I do is I label u A and I label u B. B is -2, by the way, not 2. A is x. So I will start out by writing out my A's and B's. All the ways start out with the left at the biggest A, so since I have to the fifth, it's going to be A to the fifth, A to the fourth, that's a B, A to the fourth, A to the third, A squared, A, and never an A at the end. Watch what I do here. Actually, I don't need it, because I want different colors. I'm going to be creative here. Now do your B's all the way from the right, B to the fifth, B to the fourth, B to the third, B squared, B, no B all the way to the left. So that's going to be plus sign, plus sign, plus sign, plus sign, plus sign. Now let's plug in what we have. 1 is 1, A is x, x to the fifth, plus 5 is 5, A is x, x to the fourth, B is -2, plus 10, A is x, x to the third, B is -2, -2 squared, plus 10, A is x, x squared, B is -2, -2 cubed, plus 5, A is x, B is -2 to the fourth, plus 1, no A, B is -2 to the fifth. Now it's just a terrible looking PEMDAS problem. 1 is 1, you don't need it anymore. X to the fifth is x to the fifth. Plus 5 times x to the fourth times -2, we'll clean that up. Plus 10 times x to the third. Negative 2 squared is positive 4. We'll clean that up. Plus 10 x squared. Negative 2 to the third is negative 8. We'll clean that up. Plus 5, x is x. Negative 2 to the fourth is 16. We'll clean that up. Plus 1, negative 2 to the fifth is negative 32. We'll clean that up. X to the fifth is x to the fifth. 5 times negative 2 is negative 10. X to the fourth. 4 times 10 is 40, so plus 40, x cubed. Negative 8 times 10 is negative 80, negative 80x squared. 5 times 16 is also 80, but this is positive, positive 60x, 80x. And then 1 times negative 32 is minus 32. So x to the fifth minus 5x to the fourth, 10x to the fourth, plus 40x to the third minus 80x squared plus 80x minus 32 is going to be C. So, not pleasant, but we did it. What is the third term in the expanded form of 2x plus 3, that quantity to the fifth power? All right, well, what we need to do is we need to build ourselves Pascal's triangle. And we're going to build 6 levels because you start out with degree 0 at 1, and then 1 and 1 is degree 1, and then you just start building it. 1, 2, 1. You always add these two numbers to get the in-between number underneath. 1, 3, 3, 1. This is degree, so degree 0, 1, 2, 3. So I've got 2 more to go. 1, 4, 6, 4, 1. So degree 0, 1, 2, 3, 4. And finally, degree 5 is going to be 1, 5, 10, 10, 5, 1. So in order to build the binomial theorem, we have 1, 5, 10, 10, 5, 1. Okay, now I'll label u A, 2x is going to be my A, and I'll label u B. So you always start out with your a's at the left, start out with a to the fifth power, and then work your way down. A to the fifth, a to the fourth, a to the third, a squared, a. The last one will never have an a attached to it. Do the same thing with your b. Okay, b to the fifth, b to the fourth, b to the third, b squared, b, no b there, plus signs in between. Now the nice thing about this guy is we don't have to do the whole thing. We only have to find the third term. So the third term is going to be 10a cubed b squared. We called a 2x, so 10 times 2x cubed, and we called b 3, so 3 squared. 10 is 10. 2 times 2 times 2 is 8. X times x times x is x to the third. And 3 squared is 9. 10 times 8 is 80. 80 times 9 is 720. X to the third is x to the third. B is going to be my guy. Find the slant asymptote of the function g of x equals x cubed minus 2x squared plus x minus 6 all over x squared minus 1. A slant asymptote exists when the degree in the numerator is 1 degree higher than the degree in the denominator, and that's what we have here. So we use polynomial long division to do that. Okay, put that guy underneath the division symbol. Keep in mind if you have any terms missing in between, you have to fill it in with a 0. So I don't think that happens here. X cubed minus 2x squared plus x minus 6. But that does happen here. X squared minus 1 is missing a 0x in between. So x squared plus 0x minus 1. And then you just do polynomial long division. X squared times what is x cubed? X squared times x is x cubed. So you write the x up here. Multiply x to this factor right here. X times x is x times x squared is x cubed. X times 0x is 0x squared. X times negative 1 is negative x. Now we're going to subtract the entire red row here, which means flip the signs. You become a minus, you become a minus, you become a plus. The first guy will always disappear. Negative 2x squared minus 0x squared is negative 2x squared plus 2x minus 6. Then you repeat. X squared times what gives you negative 2x squared? Negative 2. Now at this stage, we can be done. And if you're like, why? Well, because the slant asymptote is found by polynomial long division, but you don't care about the remainder. So doing the rest of this problem would only serve one purpose, and that would be to find the remainder. And we don't have to do that here. So this guy is going to be the linear equation that represents our slant asymptote, and that linear equation is y equals x minus 2. So it's going to be B. All right, so polynomial long division, we don't care about the remainder. You just have to be careful of missing terms in between, and that's how you do it. Given the table of values for f, where we have a bunch of x's and we have an f, let g of x equals f times the quantity 3 times x minus 1, close it, plus 2. What is the value of g of 2? All right, okay. G of 2 is going to equal f of 3 times 2 minus 1, close it, plus 2. So let's do some PEMDAS. F of 3 times 1, close it, plus 2 is going to be f of 3 plus 2. Well, what's f of 3? Oh, let's go to our table over here where our f of x's live. When x is 3, we get 8. So f of 3 is 8, and 8 plus 2 is 10. So g of 2 is 10, and 10 is going to be my answer. The function f of x equals x squared minus 1 is transformed into the function g of x equals x squared divided by 5 minus 1. So the only difference between these guys is x squared is being divided by 5. I don't like the way that looks. I don't like dividing it by 5. I like throwing a 1/5 out in front instead. It's the same exact thing. Which of the following best describes the transformation of the graph of f of x, which look like this, right, to g of x, which now looks like that? Well, when we multiply the x squared by 1/5, what you're doing is a vertical dilation. And when you have a vertical dilation, you dilate it by the same scale factor that that number is. So a vertical dilation by a scale factor of 1/5 is going to be the only change, and it's going to be that guy. Okay? Which means you're squeezing it down. But that's how you do it. The function f of x has a domain of -1 to 3 and a range of 2 to 4. This problem is terrible. The function g of x is -2 times the quantity f of x minus 1 plus 3 is the transformation of f. What are the domain and range of g of x? So let's sketch out what f of x could potentially look like. Okay, what it could potentially look like, and I am awful at these. So let's go out to 1, 2, 3, 4, 5, 6, 7, 8. Let's go out to 8 because that's the largest number that we see in the multiple choice options here. So let's just stick with that. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. F of x lives in between -1 and 3, so here, and between 2 and 4. So it's going to live between this, so -1 and 3 starting at 2, up to -1 and 3 to 4. So my graph is going to live here. Now what we're going to do is we're going to transform each point that we have in the corner here and see where that lands us. Okay, now let's see what we're supposed to do. All right, -2 means the first thing that we're going to do is we're going to reflect over the x-axis. Okay, that's going to be the first thing that we do. Okay, Chekaruski. The second thing that we do is that 2 means that we're going to make it 2 times taller. x minus 1 is a horizontal translation. In other words, you move, in this case, to the right. And if you're like, whoa, 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 it's negative. I know, everything is opposite inside the parentheses. This is going to have us moving right 1. And then that plus 3 on the outside is going to have us moving up 3. So we're going to take each point, right? We're going to take each point here, 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 and here. We're going to reflect it over the x-axis because that's what that negative living outside the f of x means. We're going to make it 2 times taller. We're going to then move it right 1 and then move it up 3. All right, so let's take this point down here. Reflecting that point down there over the x-axis means we're 2 above now. Let's move it 2 below. Now we're going to make it 2 times taller. If it's negative 2 feet tall, and I know that doesn't make sense, but if it's negative 2 feet tall, making it 2 times taller makes it negative 4 feet tall. So now we're at negative 1, negative 4. Move it to the right 1, move it up 1, 2, 3, and that's where we live now. Okay? So let's do it again. Okay? Take that x, which is 4 above, reflect it over the x-axis, which moves it 1, 2, 3, 4 below. I've heard of 5 below, but 4 below, that's cheaper. All right. We are now 4 below, making it 2 times taller makes it 1, 2, 3, 4. So 8 below, move it right 1, move it up 1, 2, 3, and now we're living at the point 0, negative 5. Let's do it again for this point here. Reflect it over the x-axis, 1, 2, 1, 2. Okay, so now you live at 3, negative 2. Make it 2 times taller, making it live at 3, negative 4. Move it right 1, move it up 1, 2, 3, and now you live at 4, negative 1. Okay, one more time with this point right here. It's living 4 above, so reflecting it moves it 4 below. Make it 2 times taller, so 4 below moves it down to 8 below. So now we're at 3, negative 8. Move it right 1 to 4, negative 8, and move it up 1, 2, 3 to 4, negative 5. So my new picture lives here. My new domain is going to be from 0 to 4. So my new domain is going to be from 0 to 4. And my new range is going to be from negative 1, 2, 3, 4, 5 to negative 1. Terrible, terrible, awful, gross problem, but that's how you do it. An open top box is to be made from a 24-inch by 36-inch piece of cardboard by removing a square from each corner of the box and folding the flaps on each side. Let's get a visual. Okay, so we have a piece of cardboard, right? 36 by 24. We are cutting out little boxes, okay, little squares out of each corner, the same exact square, so that once we remove that, we should be able to fold these guys up and make ourselves a nice little box that looks something like this. Perfectly drawn. That's what we're looking at. Now, can you cut out 13 inches by 13 inches from each corner? Well, if I cut out 13 inches by 13 inches, that's a grand total. If I cut it out on this side, that's a grand total of me cutting out 26 inches. That's fine. Oh, but you know what? If I try to cut out 13 inches by 13 inches, that's not 16. I take it back. That's, well, if I cut out 13 by 13, that's me cutting out 26 inches from this whole thing. You can't do that. You can't cut out 26 inches from something that's 24. So the answer is no, no. So not yes, not yes. No, because the remaining length will be negative if you do that. So that's not possible. You can't do it. So B is going to be my option. So that's what's a domain restriction. That's called a domain restriction or a restricted domain, however you want to call it. But now you can't do it. Given the following data for x and f of x, so we have all this information right here, which of the following statements is true about the function based on the differences? Well, first things first, you each go up by 2, praise the Lord. So we have equal length input value intervals going on the left. So that means what I can do is if I wanted to find out if it was quadratic or cubic, I could do the same thing over here. So linear is not the option, but we'll test its linearity by finding out what we have to do to each number to get from one number to the next. Now, what you have to be very, very, very careful of is not making a dumb little math error, which I'm deathly afraid I'm going to do. So to get from 97 to 405, you are looking at a change of 308. 977 is going to be 275, so I can handle that. 1861 minus 977. I am not typing this into a calculator off to the side, so I don't appreciate your accusations. 3105, 1861, the year I was born, is a difference between 1244, and the difference between 4757 and 3105 is going to be 1652. So yeah, not linear. So let's see if it's quadratic. Please, Lord, let it be quadratic. To get from 308 to 572, you are looking at a difference of 264. To get from 572 to 884, you're looking at a difference of 312. So it's not going to be quadratic. To get from 884 to 1244, you're looking at a difference of 1020. 1244, I'm not typing this into a calculator off to the side, minus 884 is 360. And then you have 1652, and 1244 is 408. All right, so it's definitely not quadratic. It's definitely not quadratic. So this better be cubic. So cubic is going to be 312 minus 264, which is 48. Looking at you, you're also 48. Looking at you, you're also 48. So this is cubic. And the reason why it's cubic is because the 1, 2, third differences are a non-zero constant. So the third differences are a non-zero constant. So I'm not going to lie. I would never lie to you guys. I used my calculator for this. Now, you could do this without a calculator, but that would make my video 2 times longer, which would make me 2 times more money, which is good for me, but you don't need to sit through that. But yeah, that's how you do it. The table below shows the amount of rainfall in inches over time in hours, and the pattern is linear. So we have time in hours, we have rainfall in inches. It's asking me to find out what R of 9 is and explain what it means in this context. Now, this is a calculator problem, the first one of the entire practice test. Looking at the numbers, it's not bad. It's actually really, really, really nice. So you're probably like, I don't need a calculator. And you're right. But what I'm going to do, just for the sake of practice with this problem, is I am going to show you how to do this on a calculator so that you have the practice and you know what to do in the future. So let's go off to the side and do just that. All right, so in order to use linear regression to come up with an equation, we're going to go to Stat first and Edit. We're going to plug in our numbers on the left. So the x values will go on the left. They started with 0 and then just went up by 1 up until 5. Okay, over here we had 0, and then they were the even numbers, easy peasy. Again, you could do this without a calculator, but the purpose of this is to show you how to use the calculator to do it. Right, so the problem is asking me to find out what R of 9 is. In order to do that, I need to come up with my equation. So I'm going to go to Stat, Calc, and this is linear, so I'm going to use 4, which is linear regression. Now, since I'm going to use this equation for later, I'm going to store my regression equation into the y equals. So I do that by going to Store, Reg EQ, hit vars, go to y vars, and hit enter to go into function and enter to store that in y sub 1. So now when I calculate this, it's going to live in y equals. So you go down, you hit calculate. This shouldn't come off as a surprise that based off of the numbers, we have y equals 2 times x, or I guess technically in this case, r of t equals 2t. But if I go to y equals, there's my equation waiting for me. And that's why we do this process. Now it wants me to find out r of 9. So an easy way of doing this is going to second table, scroll down to 9, and that gets me 18. All right, so let's go back to the problem, answer that, and explain what that means in this real-world context. So r of 9 ended up being 18. Now what that means is this was a t, and this is r of t. So that means after 9 hours, we can expect 18 inches of rainfall. And that's what we get here for A. On what intervals is the function decreasing? So we're given this graph, and our job is to find out when the function is decreasing. Well, by definition, the function is decreasing as when you move along the x-axis, you're going down and to the right. It could be a straight line, it could be a wobbly line. All you care about is our graph going down and to the right? Well, here it is going down and to the right and stops doing that at -1. Including -1? No, but at -1. So we can say from -infinity to -1, our function is decreasing going down and to the right. From -1 to +1, we're increasing, and then from 1, we're going down and to the right again. And it's not consistent, but it doesn't have to be. It's just going down and to the right, down and to the right, down and to the right. So it picks back up from 1 to +infinity. So we'll say union 1 to +infinity. That is where our function is decreasing. Now let's take a look at B and understand the difference between what's being asked. B is asking on what interval is the rate of change, not only negative, but decreasing. Rate of change is a fancy word for slope. So it's asking when is the slope negative. That does mean down and to the right, but also if the rate of change is decreasing, that also means concave down. So we need the part where it's going down and to the right and also concave down. So let's see what we marked up here in blue and see if any of this is concave down. And it doesn't look like it is. I mean, this is a possibility, but I'm going to keep going with the fact that this is concave up still, and concave up. It doesn't appear to be concave down until we hit 0, but here's the thing. At 0, our function, or better yet, our rate of change is positive. Here, this appears to be concave down. Okay? It also appears that this guy is concave down. Okay? So I'm going to go with the fact that I'm going to not include 1.5 because 1.5, it kind of seems like it's neither. So what I'm going to do is I'm going to say that it's concave down from 1 to 1.5 union, and then picks back up from 1.5 to infinity. So make sure we understand the difference between the two, the difference between rate of change is decreasing and the function is decreasing. One means that, the other means that. Name the two intervals that have the same positive average rate of change. Now, average rate of change means, slope between 2 points if we're looking at a graph. I want a positive rate of change. Well, that's only going to happen between here and here because that's the only part where I can draw a positive slope. If I were to draw a dot here and a dot here and find this slope here, that goes up to right 1. If I were to do the same thing here and here, that also goes up to right 1. Now the pictures and the curviness of the graph may not be the same, but that doesn't matter here. I only care about the slope. Okay, so it appears to me that between -1 to 0 and 0 to 1, we have the same average rate of change. So I'm going to go with that. So that's our first free response question. Tons of fun. Given the function p of x equals negative x times the quantity x minus 4 squared times the quantity x plus 5 cubed, answer the following questions. So we have this polynomial here in factored form. We got a negative out in front. We got 1x living out there. We've got 2x's living in here. We got 3x's living in here. Okay. State the zeros and the multiplicity of each. So part one is not so bad. You take a look at each factor and you would say, all right, well, the number that would make negative x become 0 is just 0. Easy peasy. The number that would make x minus 4 0 would be 4, and the number that would make x plus 5 0 would be negative 5. Okay, so those are my three zeros. So my zeros are x equals 0, 4, and negative 5. Now the multiplicity for each, multiplicity, is completely dependent on how many exponents are attached to that factor. Negative x has an invisible exponent of 1, which means the multiplicity is 1. 4 has a multiplicity of 2 because of its exponent, and negative 5 has a multiplicity of 3 because of its exponent. Okay? So there you have it. There's our multiplicity. There are our zeros. Now we can use this information, plus a little bit more, to answer B. B wants us to find out where P of x is positive. So this is what I need to do. I'm going to draw myself a simple sine graph. I'm going to mark my zeros, which were negative 5, 0, and 4. I need to find out what my zeros are. Check. I need to find out what the multiplicity is. Check. But what I also need to do is find out the behavior of the graph. And the way I do that is I use the fact that I underlined these x's. I underlined a negative x. I underlined two x's here, right? Because there's two x's. It would be x minus 4 and x minus 4. So I'm going to multiply x squared. And I underlined three x's here, so I'm going to multiply x cubed. Now, by underlining and multiplying the leading terms of each factor, I am finding out what type of graph this is. Negative x times x squared times x cubed is negative x to the 6th power. That is an upside down, I guess, is it sextic? I don't know. Looks like that. That's all I know. Now, this is what I also know. Since I know the multiplicity for 4 is 2, it's going to bounce off of 4. So as I start writing this out, as I start drawing this out, okay, it starts from the bottom like Drake does. It's going to go through negative 5 because it has an odd multiplicity. So it's going to go through negative 5. It's going to come back up, maybe do a wobble here and there, but who cares? Go back down and go through 1 because it has a multiplicity of 1. But when it comes up through 4, okay, it's going to bounce off of 4 because of that even multiplicity. Now, somewhere up here or down here, we have more bumps, but that's not my concern right now. If you want me to put a bump there, go ahead. That's not my concern. My concern is where is this positive? And it's positive at one spot, and it's that interval right there, from negative 5 to 0. Now, do we include negative 5 in 0? No, because we only want it to be greater than 0 and not greater than or equal to. So we want the spots that are only greater than the x-axis, only above the x-axis and not touching it. So we will say negative 5 but not including, all the way to 0 but not including, and that's it. Now, if we did include 0, then we would put brackets here, and we would also include 4. But we don't have to do any of that because we only care about when it's above the x-axis and not when it's touching. Now, last but not least, we are going to be asked to write out the end behavior in limit notation. We know what the graph looks like. We know it looks like that, which means we know that as x decreases, my graph goes to negative infinity. So how do we write that out as limit notation? The limit as x approaches negative infinity of p of x is also negative infinity. As my graph goes to the left, it goes down. Similarly, as my graph goes to the right, it also goes down. So we would say the limit as x approaches positive infinity of p of x is also negative infinity. Okay, so that's free response question number 2, all about polynomials, baby. Let r of x equal x times the quantity x minus 4 times the quantity x plus 2 in the numerator and x squared plus 5x plus 6 in the denominator. State all wholes and vertical asymptotes. I guess we're not worrying about zeros. Oh, I see why. I don't know why there's an Oxford comma there. I'm not going to complain. I'll just blame the person who made this problem. So in order for us to do that, I need to make sure both the numerator and the denominator are completely factored. So the top part is good, x times x minus 4 times x plus 2, all over, factoring u is two numbers that add up to 5, multiply out to 6, are x plus 2 and x plus 3. Now, there's 5 factors, which means there's 5 magic numbers. And the magic numbers are the numbers that make each factor equal to 0. For example, plugging in 0 makes x 0. And that makes the whole thing up here 0 and all that fun stuff. Plugging in 4 makes this factor 0. Plugging in -2 makes that factor 0. Plugging in, -2 makes that factor 0. And plugging in -3 makes that factor 0. Now, I'm going to label all of these what I know that they are. Okay, get it out of the way, even though I'm going to accidentally answer B a little bit, no big deal. Anything that has just a factor in the numerator and nothing like it in the denominator is going to be a 0. So 0 is a 0 and 4 is a 0. Now, anything that is in the numerator and the denominator the same amount of times is going to be a whole. So -2 is a whole and -2 is a whole. Anything that's in the denominator all alone is going to be a vertical asymptote, so -3 is a vertical asymptote. Now, when we throw multiplicity in here, that changes the game slightly, and you have to worry about which one's more dominant, the top or the bottom or whatever. But it seems like we don't have to worry about multiplicity, not at all. All right, so in order to answer A, state all wholes. Well, my wholes are going to exist at x equals -2, so just one of them. So whole is x equals -2. And my vertical asymptote is going to live, at x equals -3. Now, x-intercepts, you might be thinking, what the heck is that? X-intercepts is just a fancy word for 0. So just, changing the words up a little bit. X-intercept is going to exist at 0 and 4. So x equals 0 and x equals 4. Now, how do I figure out the y-intercept? Well, the y-intercept is found by taking the constant upstairs. So let's say it's 5, and the constant downstairs, and let's say it's 3, and just simplifying that. Well, here's an issue with this. If we look at the problem that we have, okay, if we were to look at all the factors, technically, this can be written out as x minus 0. So if I were to multiply all the numbers up here, all the numbers up here, all the numbers up here, I would get 0 times -4 times 2, which is 0. Okay, and so down on the bottom here where I have 6, I would get 0 divided by 6, which means 0 is going to be my y-intercept. Now, why would this make sense? Let me write that out and tell you in a minute. If the x-intercept is 0, that means whatever this picture looks like is going to go through the origin, which means, of course, the y-intercept is going to be 0. Everything makes sense. Now, this last one's not going to be that much fun, although I purely enjoy it. Okay, my job is to find the equation for the slant asymptote. The slant asymptote exists when the numerator is 1 degree higher than the denominator, and then we do polynomial long division. In order for us to do that, though, I need to completely FOIL this guy out. So I have x times x minus 4 times x plus 2. So let's do x times that guy. X squared minus 4x times the quantity x plus 2. Let's FOIL this out again. X cubed plus 2x squared minus 4x squared minus 8x. And then combining these two, you get x cubed minus 2x squared minus 8x. Now what I'm going to do, since we're going to do polynomial long division, is I'm going to attach a plus 0 at the end because it makes it look pretty. So let's set this guy up. All right, underneath the division symbol, we have x cubed minus 2x squared minus 8x plus 0. Underneath here, we have x squared plus 5x plus 6, and then we do a little bit of polynomial long division. X squared times what is x cubed? X squared times x is x cubed. So you take that x, multiply it to this whole factor down here. X times x squared is x cubed. You will always get the same thing here, otherwise you did it wrong. X times 5x is positive 5x squared. X times 6 is positive 6x. Now you subtract that entire row, which means you flip the signs. So u will go away. Negative 2x squared minus 5x squared is negative 7x squared. Negative 8x minus 6x is negative 14x. Drop down to plus 0. Let me do it again. X squared times what is negative 7x squared? Negative 7. Now here, I can stop. And if you're like, whoa, 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 whoa. Why? We're not done the problem. I know we're not done this problem. But what I need to do is, in order to find the slant asymptote, you are trying to find what happens before the remainder. I don't care about the remainder. All I know is I'm going to get a linear equation y equals x minus 7. Doing the rest of this problem would serve one purpose and one purpose only, to find the remainder, and I don't need that. So the slant asymptote is going to be the linear equation y equals x minus 7. Okay, so we can stop right there. All right, so this kind of gives us a little snapshot of what this looks like. We know that we have a slant asymptote of x minus 7. We know we have x-intercepts and y-intercepts and holes and vertical asymptotes, and we can draw ourselves a general picture of what this guy will look like. Not that we had to, but we have a good idea as to what this guy will look like. All right, so that is the third free response question. One more to go. We've made it to the last free response question in this fake practice test for Chapter 1. The table below shows the poll ratings of a politician over time. Boo! Is the data best represented by a linear, quadratic, or cubic model? Explain your reasoning. Calculator. So what we're going to do is we're going to let our calculator literally do all the work for this. Okay, so probably for every single problem, for every single problem, we're going to go off to the side and let our calculator do the job. You might be thinking, well, in order to find out if it's linear, quadratic, or cubic, can't we do the thing where we see how much it goes up by and then do it again and then do it again? We can. But if these numbers are not exactly linear or exactly quadratic or exactly cubic, that won't work. So I'm going to let my calculator do all the work. So that's what we're going to do for part A. For part A, we're going to throw this into our calculator. We're going to see what kind of model it appears to be and explain why. So let's go off to the side and do that right now. All right. My job is to find out if all that information is going to be linear, quadratic, or cubic. So I'm going to go to Stat, I'm going to go to Edit, and I'm going to put in all that info. So the month is going to be all the stuff under L1, so that's just going to be 1 through 12. So type that out, or in this case, watch me type that out, like so. Make sure you make no typos. I think I can handle doing 1 through 12. Now for L sub 2, that's going to be the rating. So 1 matches up with 12, 2 with 18, 25, 32. If you don't want to listen to me say the numbers, you can just fast forward a little bit, or this would be a good time for you to drop a comment. Tell me how much you like my stuff. I see a lot of YouTube videos where people are like, make sure you drop a comment. So that's what I'm doing, and of course while doing this I'm getting very distracted. I can't multitask. What do we have? 35, 42, 49, 56. All right. Now again, my job is to use this information to see if it's linear, quadratic, or cubic. Okay, right now I just have a bunch of dots. If I were to hit graph, nothing. So what I need to do is while I'm in this section, not even while I'm in this section, we'll just make believe that never happened. Okay, this is what I have. In order for me to see the dots, I need to do a few things. I need to go to second y equals to take me to stat plot. Now what I just did is I put a bunch of stuff into stat, which means I gave my calculator 12 points. I'm going to want to hit enter Enter to turn the stat plot on. And what it's going to do is it's going to show me the points. Now, there's an issue. My numbers were all double digits, so if I were to hit graph, I still won't see anything. So what I want to do is I want to see those stat points by going to Zoom and going to 9 Zoom Stat. Now what we have here is a picture that goes up, comes back down, and goes up. Now this is not an exact science, okay, but this appears to be cubic. All right, I can draw a line, perfect no, but draw a curve rather that kind of creates a cubic function, okay, that looks like that. All right, so if we were to do the old-fashioned, let's go to the table and find out how much it goes up and then do it again, you're not going to be happy with the results. So by doing it this way, we were able to say, all right, even though it's not perfect, that definitely looks cubic because it follows the cubic pattern. So we were able to look at that information, and even though it wasn't perfect, it's definitely a cubic model because it follows a cubic pattern. Okay, so again, it's cubic because it follows like a pattern that looks like that. Okay, not exact, but close enough. Using your calculator or software, determine the equation for the regression curve that best models the data. Now that we know it's cubic, we can run off to our calculator, use the information that we already have plugged into this guy, and run cubic regression to give us a probably really gross but somewhat accurate equation. So let's go off to the side and do just that. Now, in order for me to find the equation of the regression curve, I already have my information plugged in. So I'm going to go to Calc here. I'm going to go to Stat first. Calc here. We determined that this was cubic, so I'm going to do cubic regression. Now, part C is going to ask us to use this equation for later use. So before I answer B, I'm going to do something that'll help me for part C. So I'm going to go down to Store Reg EQ. Okay, I'm going to save the answer that I get into my calculator so that when I do get to part C, life is a lot easier. So by doing Store Reg EQ, I go to vars, go to yvars, hit enter, enter, and this is now going to save my equation into the y sub 1 part of y equals here. So this will help me for part C. But part B is me going to calculate, hitting enter, and getting that god-awful mess. So we're going to write out y equals 0.161 x cubed minus 3.0130, because that's going to round up again, so that will be x squared, plus 19.849x minus 7.364. And so we'll go off to the side and write that out. So we ended up with y equals 0.161 x cubed minus 3.130 x squared plus 19.849x minus 7.364. Use the regression equation to find the average rate of change in the politician's rating from May, which is month 5, to October, which is month 10. Explain what this rate of change means in the context of the data. So I was kind of wrong when I was like, oh, let's make sure we store this into our calculator. I was wrong, but I'm still going to go back and pretend like why that might be useful anyway. In this case, all we really have to do is use the information that we're given. Okay, if we're using the average rate of change, that's this formula right here, the same formula that you used a bunch of times, like so. Okay, U would be my A, and U would be my B, so 5 would be my A, and 10 would be my B, and then U would be my F of A, and U would be my F of B, right? So I'm going to run to my calculator, I'm going to figure out what 42 minus 41 over 10 minus 5 is, which I don't really need my calculator for, but I'm going to show you how to do that anyway because it's important to know what to do with fractions in your calculator. And I am going to demonstrate why maybe storing something like that into your graphing calculator might be useful for a different type of problem. Now to answer part C, what we're going to do is we're going to use that table. Okay, and even though I technically didn't need the equation, I thought maybe I would, I didn't need to. All that information is there stored for me. So if for some reason I asked you to do like the 14th month or something like that, what I could do is I can go to second table, scroll down to whatever I need, and do the 14th month or something like that. But I don't have to do that. I don't have to do that in this case, so I kind of jumped the gun, but I'm glad I did it because it showed you how to store those equations anyway. What I have to do here is use the average rate of change formula. So if I'm going from month 5 to month 10, I'm going to make sure I have 42 in one set of parentheses, 42 minus 41 in the other set of parentheses. Divide that by 10 minus 5. Now, I didn't need my calculator for this. I just wanted the excuse to show you that other thing. This is going to be 0.2, which is 1/5. So let's go back and change that. We're happy now. Thanks for watching. Finish the problem. All right, so we ended up with 0.2, which is also the same as 1/5. So what that means, explain what this rate of change means in the context of the data. That means that you only averaged 1/5 of a point in your rating in these 5 months. Okay, so this was only a 1/5 ratings increase over that interval. Not much, but that's what it means. So that's our last free response question. I hope this helps. I hope watching these videos helps you get ready for everything you might see in a Unit 1 test, whatever that might look like for you. But thank you very much for watching. I'm making Unit 2 and a Unit 3, so more to come, more to come. All right, thank you guys. Love you. Bye.